Yeah. So, good evening, all. So, myself, I'm Vijay. I hold nearly 17 plus years of experience, which includes nearly 8 plus years of experience in Hadoop and Spark environment, right? So, as part of today's demo, I'm going to cover the following topics. So, before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
Yes, sir. Screen is visible, sir.
Fine, thank you. So, what is big data? Why Hadoop and Spark? And what are the drawbacks we see with the current databases, right? Drawbacks with current databases, right? Hadoop and Spark advantages. Hadoop and Spark advantages. Yes. Hadoop and Spark components. Hadoop and Spark job market. Fine. Yes. So in today's session, mostly I discuss about big data and Hadoop, right? In the tomorrow session, I'll be discussing mostly on Spark and advantages. Yes, its features. What is big data? What is big data, right? The name itself saying, right? Huge volumes of data. You see the current, how the data is stored currently, right? Data storage units like KBs of data, right? MBs of data, GBs of data, gigabytes, terabytes, petabytes, exabytes, right? Zettabytes, etabytes, ottabytes, so on, right? Yes. So from TB onwards, we see like huge data, right? Or big data, right? So do you think like, okay, you should have seen KBs of data, MBs of data, or even GBs of data, right? But do you think like petabytes of data, is it getting generated in the current real world, right? 1 petabyte equal to, right, 1024 TBs. Already 1 TB is a large storage unit, right? Do you think like 1 petabyte, right? Yes, 1 petabyte equal to 1024 TBs. So already 1 TB is a large storage unit, right? 1 TB is a large storage unit. So here 1024 TBs forms a petabyte, right? It forms a petabyte. So do you think like petabytes of data or exabytes of data, is it getting generated in the current world? If so, examples of petabytes of data generation. Petabytes of data generation. Talk about a banking sector. Like, yes. If you take example of any bank like SBI or HDFC, right? We see within the city, we see hundreds of branches. Within the entire state, we see thousands of branches, right? Within the entire country, lakhs of branches for SBI. Again, within each branch, we call, say like millions of customers, each customer making multiple transactions per hour, per day, per week, per month, per year. Each and every transaction need to be stored, right? So huge data. And forget about this, everyone aware about the social media like Facebook, right? Facebook, it has got users not only within the country, it has got millions and trillions of users throughout the world. What is the data generated by Facebook in a minute? How many posts and videos are getting circulated? What should be the storage capacity to store all the videos and posts, right? So not like you see, like it's what is the data generated means not in MBs or GBs, like terabytes and petabytes of data. Not only like Facebook, right? Today we have got many applications. Today, if we talk like many applications are generating data in petabytes. They are generating data in petabytes, right? Yes. 1 minute, if I talk about 1 minute of transaction, right? 1 minute transaction, right? Yes. In a minute, how many FB post, Facebook post, right? Yes. What is the data generated by Facebook? In a minute, how many Twitter tweets? What is the data generated by Twitter in a minute? What is the data generated by Google, right? Google queries, right? What is the data generated by YouTube videos upload? YouTube videos upload, right? Yes. So huge data, right? What to store all the videos, everyone creating their own videos and uploading in the YouTube, right? What should be the storage capacity to store all the videos? And everyone, right, has got millions and trillions of users using email messages, right? Email messages. Each and every message need to be stored, right? What should be the storage capacity to store all these messages? Or bank transactions. Just now I was talking about the bank transactions, or if it like telecom transactions, or like Flipkart or Amazon transaction, right? Like e-commerce transaction. Everywhere we see like huge data, right? Yes. Not in GBs or TBs, petabytes of data. All these applications storing petabytes of data, right? Yes. Okay. Currently we have got databases, right? Currently we have got databases like we see like databases like Oracle, MySQL, right? We have got databases like Oracle, MySQL, DB2, SQL Server, right? All these databases, right? They are used for OLTP, online transactional processing, for day-to-day operations, right? But if you see, we have got some specialized databases. We have got some specialized databases used for data warehouse purpose, right? Like we got Teradata. If you heard about like Teradata and Netezza, Vertica, right? Yes. These are used for OLAP, data warehouse purpose, right? DWH, data warehouse purpose, right? Online analytical processing, OLAP, online analytical processing, right? Yes. Databases and specialized databases both are used for, right? Okay. Okay. Now these databases or specialized databases, they can handle data up to some extent, like databases in GBs of data, specialized databases in TBs of data, right? But to handle petabytes of data, right? We doesn't see these databases cannot handle like petabytes of data, right? As a solution to all these storage level problems, right? Not only storage and also processing level, right? We have got a framework like Hadoop for storage and processing. Later, I'll come back to this. What are the Hadoop and Spark services? But before that, if we talk about this, how this data is getting generated, data generations, and if you see data sources and data types, right? If talk, if you take, for example, if you take this is your data available, this is your data, right? Available. This data got generated from the last 50 years. Assume that from 1973 to 2023, right? This is the data which got generated, right? If you compare this data, right? Yes, if you see from 2013 to 2023, last 10 years data comparison with previous 40 years, right? See, previous 40 years. Only like if you see 20% of the data has got generated from the last previous 40 years, and nearly 80% of the data what we see currently has been generated from the last 10 to 15 years, right? The reasons for huge data generation especially from the last 10 to 15 years, right? Because of usage of technology, usage of smartphones, usage of internet, right? Because of which huge data is getting generated from the last 10 to 15 years. And also, what are the main sources from where this data is getting generated? Mainly three sources of data, right? Three sources. If you go back to, especially from last 10 to 15 years, this data has been, but if you see in 1990s or in early 2000s, right? The data was very less. We have got floppy disk. We used to carry data in floppy disk, 1.44 MB, right? Later you got compact disk, DVDs, like USBs, right? So day by day, you see like data increasing, the storage systems also increasing. In the earlier stages of mobile phones, like just 128 MB storage, you need to have in 2001 or 2002 at the earlier stages of mobile phones. The internal storage was 128 MB or 256 MB, right? But now even 128 GB is a very small storage. So is data increasing, right? So the storage systems also need to be increased. From where this data is getting generated means mainly three sources, right? Three sources of data. You can say like a social data, machine data, and a transactional data, right? Three types: social data, machine data, and transactional data. See, what is social data? Data which got generated from social sites, right? Like Amazon, like Facebook, Twitter, all this, right? And machine data means the data which got generated by reading or scanning the barcodes, RFID chips. So whenever you go to any shopping mall, right, for the items you purchase, you will get huge data getting generated, right, by reading or scanning the barcodes. Such data we call like machine data. And transactional data, like day-to-day operations, like bank transactions, telecom transactions, right? And what are the main types? Like three types, right? They are going to occupy three types of data. Three types of data, like structured, unstructured, and semi-structured, right? Structured data, semi-structured, unstructured, right? Structured data, semi-structured data, and unstructured data. Data which is organized in the form of rows and columns in a structured format, like DB tables, like Excel files, DB tables, database tables, right? Everything we call like structured. Semi-structured means they are not fully structured, they are not fully unstructured, right? Like XML files, JSON files, right? Yes. Unstructured, like short messages, articles, images, videos, all this comes as unstructured. The biggest challenge is like storing and processing this unstructured data. Today, if you see, most of the data which is generated occupying this unstructured format, right? We need to have proper storage and processing systems to handle this unstructured and semi-structured kind of data, right? If we talk about databases, they can handle only structured data. They can process the structured data, right? So Hadoop is a kind of technology which can store and process this huge data, right? Yes. So as a solution to all the storage and processing level problems, we have got a framework called Hadoop. We have got a framework called Hadoop. Hadoop is meant for two things. So, okay. So Hadoop is, we have got a framework called Hadoop. Hadoop is meant for two things. Hadoop provides two services: storage and processing, performs two things: storage and processing. Okay. Storage plus processing, right? Yes. So if you talk about any technology, right, they perform either storage or processing. If you talk about C or C++ or Java, .NET, right, all these, they are meant for processing. They are meant for processing, right? Yes. And if you talk about Oracle, MySQL, DB2, all this meant for storage. They are meant for either storage or processing, but Hadoop performs both storage and processing. But for storage, does Hadoop use any database internally? No. Hadoop is going with a kind of file system called as Hadoop distributed file system. And for processing, we are going with an execution model called as MapReduce. And currently we are using Spark, right? Yes. So for storage, we are using this. For processing, we are using this, right? Both combinedly can store and process. And you may get doubt, right? When Hadoop is able to perform storage and processing, what is the use of the current processing and storage technologies, right? So do you think that they will be away from the market when Hadoop in the market where it can perform storage and processing? No. You need to know where this Hadoop and Spark is used for batch processing, for batch application, right? Means millions and trillions of records go for Hadoop or Spark. For one record or two records, we no need to go for this Hadoop or Spark, right? And go with databases. For online processing, for day-to-day operation, go with the databases for one transaction or two transactions. For millions and trillions of records, right? Go for Hadoop, right? Yes. Now coming to this, right? Yes, understood, right? What is big data, Hadoop, right? So if I take big data, huge data generation, if I take big data as a problem, huge data generation, then I can say like Hadoop as the solution for it, right? Or if you take like big data as a big data as a concept, Hadoop as the solution for it. Right. So now you may ask a query, why databases like Oracle is not used for storing Hadoop's data? Drawbacks with the current databases, right? Yeah, drawbacks with the current databases. So first thing, right? Most of the databases, right? Most of the databases, less storage, very less storage. They can handle in GBs or in TBs, right? GBs or TBs. Mainly, most of the databases, no parallel processing. No parallel processing in most of the databases, right? And if volume increases, right? If volume increases, saying like speed decreases, right? Yes, speed decreases. If volume increases, speed decreases. For example, to justify this, select total amount, sum of amount, right? Total amount from sales one. Sales one is the table, right? It's consisting of 10 records. Assume it has got only 10 records. And see one more query, right? Select sum of amount, right? Sum of amount from sales to. From sales to, it has got like 1 lakh records. Total amount from sales one, 10 records. Total amount from sales to 1 lakh records, right? Select sum of amount, total amount of, yes, one crore records. 10 records, 1 lakh records, 1 crore records. 10 records, 1 lakh records, and 1 crore records. So which query is going to execute faster among these three, right? Yes, everyone. Either 10 records or 1 lakh or 1 crore. Which record, which table, like this or this or this? Which one is going to execute faster? So the first query, right, executes faster because total amount of 10 records as compared with 1 lakh or 1 crore, right? So query to query, as volume increasing, speed decreases, right? And if you talk complexity increases, if complexity increases, right, speed decreases, complexity increases, speed decreases. For example, select sum of amount from sales one. Assume this if complex from sales one, right? Yes. You got some 1 lakh reports. Assume that you got 1 lakh reports. Next series, select average amount. Select average amount from sales one, right? Yes. Select sum of amount from sales one, 1 lakh records, average amount from sales one, 1 crore records. So sorry, 1 lakh only. Assume sales one, same table, right? Select the standard deviation of amount, standard deviation of amount, right? Standard deviation of amount from sales one. So all this, right, has got like 1 crore records, sorry, 1 lakh records, same sales one only, right? 1 lakh records. Which query executes faster among these three? Sum of amount from sales one, average amount from sales one, standard deviation of amount from sales one, right? First query again, right? Yes, because average amount is a two-step process. First sum to be calculated, next average to be calculated. Standard deviation is a lot of internal processing required. So again, the first query executes faster as compared with the other two, right? So here query to query, right? Query to query as well as this. Query to query as complexity increases, speed decreases, right? Yes. And the major drawback with the databases, right? Databases can handle only structured data. Databases can handle only structured data. They can handle only structured data, cannot handle unstructured or semi-structured kind of data. For example, if you want to take reviews for a particular movie, right? Yes. So the table name is reviews. User 2, user 3, 100 users, right? 100 users. Review, right? Yes. Movie is good. First person saying movie is good. Second person saying movie is not good. Okay, for example, think that they are giving reviews in the form of ones and zeros. First person saying 1, second person saying 0, 1, 0. In this way, the reviews are given in the form of ones and zeros. 1 means good, 0 indicates bad. Can you write an SQL query to count the number of ones and zeros? Means how many saying it's good and bad, right? We can write an SQL query for this, right? Count aggregation. Select review wise count, review wise count from which table? Reviews table. Group by review. Review wise count from reviews, group by review. What is the output, right? Yes. Zeros and ones, right? 1 and 0. What is the count? 90 people saying the movie good, 10 people saying the movie bad, right? Assume. This kind of structured data, okay. But if the reviews won't be given in the zeros and ones, right? They give the reviews in their own text format. First person saying movie is good. Second person saying movie is not good. So in this way, they are giving in their own text format. They are giving the review in their own text format, right? Giving the review in their own text format, right? So here 90 people saying movie is good and 10 people saying the movie is bad, right? Now, can you write an SQL query, right, for this? If they are writing in the text format, how many people saying good, how many people saying it's not good, right? We cannot write a query even based on keyword count. If you try to see, right, if you want to count based on keyword, still it gives wrong computation because even not good has got good within it, right? So the major drawback with databases can handle only structured data. But if we talk about this Hadoop advantages, right? Hadoop advantages. First thing, unlimited data storage. Unlimited data storage. Unlimited data storage. And secondly, very high speed processing. Very high speed processing. And can handle all varieties of data. Can handle all varieties. Unlimited data storage, very high speed processing, can handle all varieties of data, right? Okay. Open source, no licensing required, right? Open source. Unlimited data storage, very high speed processing, can handle all varieties of data, open source, no licensing required. Okay. Unlimited data storage, right? Unlimited data storage, very high speed processing, right? So if you see examples, Yahoo has conducted a test, right? Yahoo has conducted a test to check the speed of various databases. It has taken a table, Yahoo has taken a table, right, of 100 TB. Has taken a table of 100 TB, right, consisting of 1024 columns. Task, right? Task. Yeah, task, right? Sorting based on 16 columns. Sorting based on 16 columns, right? Yes. What is the time taken by various databases? Time taken by various databases. First one, right? Oracle has taken nearly 3.5 days to process this, right? MySQL, right? MySQL, it has taken nearly 6 days to process it. 6 days, right? And if you talk like specialized databases like Teradata used for data warehouse purpose can handle TBs of data just taken 4.5 hours, right? Yes. Another specialized databases like Netija, right? Right. It has just taken 3 hours to process this. But finally, Hadoop, right? has just taken 3.4 minutes, 3.4 minutes, and latest version of Hadoop has taken just 1.2 minutes, right? If you talk about Spark, it will take seconds, right? If Hadoop's Spark speed is more faster than Hadoop. So this is what the Hadoop speed, right? Compared with other things where they have taken days and hours, Hadoop has taken just minutes of time. That is Hadoop is proven in the market, processing point of view, right? And even in the storage point of view also, Hadoop is proven, right? So you may, okay, processing point of view, right? Very high speed processing. Today, if we talk like most of the projects like ETL kinds of projects, they're migrating towards Hadoop and Spark environment, right? Yes. You may ask like why databases like Oracle, why I got see this query, right? Why databases like Oracle, cannot support unlimited storage, right? Yes. Why databases like Oracle cannot support unlimited storage? Why only Hadoop can perform? Why not this? Means Hadoop follows master and slave architecture. Single master and multiple slaves. Multiple slaves means a single master and multiple slave systems. But here there is a limitation for this. For this limitations, right? Databases and max limit on the number of slaves. Max limit on the number of slaves. Like if you talk like Oracle, right? It can have maximum 256 slave systems. 256 nodes are slaves, right? Slave systems. Beyond that, it cannot, right? It cannot support data. Once these 256 slaves or systems gets filled, it cannot support data further. If we talk like MySQL, just it can support only 54 slaves. Supports only 54 slaves. Yes. MySQL Express, right? MySQL Express, it can support nearly 256 slaves. And DB2, right? It supports nearly like 256 slaves. Oracle, MySQL Express, DB2, SQL Server, right? Yes, SQL Server, right? Like 256 slaves. Right. So they can support only up to 256. Beyond that, they cannot support, right? But we have got some specialized databases like Teradata, right? Teradata, it can support nearly 512 slaves, right? Systems for storing its data. And Netija, right? It can also support, right? 512 slaves. Vertica also can support nearly 512 slaves for storing its data. Okay, MySQL Express, DB2, SQL Server, Teradata, Netija, Vertica. But Teradata and Netija, now they are supporting nearly 1024 systems or slaves, right, to store its data. And Netija also supporting 1024, right, 1024 slaves for storing its data. Right, but still I cannot say like they are storing unlimited storage is possible. No, once they get filled, they cannot support data further. But there is no limit. There is no limit on the number of slaves. That Hadoop can have, right? Yes. But there is no limit on the number of slaves that Hadoop can have. unlimited number of slaves, right? So that. So Yahoo, when first time implemented Hadoop, Yahoo, when first time implemented Hadoop, went with 4,000 slaves, 4,000 slaves for storing its data. And currently it is going with currently Yahoo using nearly 12,000 slaves or nodes, right, for storing its data. Facebook, right? Facebook, when first time implemented Hadoop, went with 8,000 slaves for storing its data. Currently it is going with, right? Currently it is going with 12,000 slaves for store, sorry, 42,000 slaves, right? 42,000 slaves for storing its data, right? Means there is no limit like the databases going with 256 or 512, but here they can go with the thousands. There is no limit on the number of slaves that Hadoop can have,
Vijay,
right? Yes.
Vijay, sorry to interrupt. Can you please repeat what is the slaves and nodes are?
Yes, that I'll be discussing, right? So one second. See, Hadoop follows a single master, multiple slaves, master slave architecture. So Hadoop or Spark follows, right? Master slave, not client server architecture, master slave. Single master means these are multiple slaves. Slave nodes, we say. This is master node, these are slave nodes. Group of nodes, CPUs. Group of nodes are CPUs. They are connected in a network. One master node and all are nodes are slaves, nothing but systems, CPUs. One master node and multiple slave nodes. So in Hadoop, if there is a file, in Hadoop, data is stored in the form of files. The data f1.txt, think that your system or the slave 1 TB, 1 TB, 1 TB, means each system storage is 1 TB, 1 TB, 1 TB. Slaves nothing but system, nodes. Master node means it's a one system, slaves and multiple systems, right? So each system capacity 1 TB. My file size is 2 TB. This 2 TB cannot fit into any of this file, right? Any of this system, it cannot be accommodated by any system, right? So in Hadoop, data is going to be split into smaller parts. It is going to be split into smaller parts and will be first part in one system, second one in another system, this in another system. Means distributed storage, you see. The data is going to get distributed across multiple systems and processed by multiple systems. Two advantages what we can see. Huge data file can be accommodated. Secondly, as it is distributed across multiple systems, they are processed parallelly. They are processed parallelly, right? Yes. Okay, they are processed parallelly. Okay, so we'll see very high speed, right? Because a single file distributed across multiple systems and is processed parallelly, very high speed. See, if work done by one system, work done by multiple systems, means work done by one person and work done by multiple persons. You can see that speed, right? Yes, that's what high speed. Okay. So these are the systems, means Hadoop, horizontally unlimited number of slaves. Horizontally, you can keep on adding the systems or slaves, right? Slaves means systems. We can have any number of systems. There is no limit, but for databases, there is a limit. Yeah, how many systems can be? And Yahoo, Facebook went with 42,000 systems for storing its data. Initially, it was using 8,000. Currently, it is using this. Means there is no limit on the number of systems that Hadoop can have. Slaves, right, can have, but there is a limit in other databases. So storage point of view, it is proven, and the processing point of view, it is proven in the market, right? Yes, understood, right? What is Hadoop, why Hadoop, right? And drawbacks with the databases, Hadoop advantages, right? And most of these today, if you see most of the applications generating huge data, so to be stored and to be processed, these big data tools are mostly preferred, right? Yes. One second. Now see these advantages, and as compared, some tests were conducted by Yahoo to check the speed of these databases, where Hadoop has taken minutes of time, where the other things they have taken like days and hours, it has taken minutes of time. And why databases like Oracle or this cannot support means they have limit on the number of slaves. Fine. So if you see, and if you talk about Spark, right? Spark, a very high speed processing technology, right? Used currently, it has got great demand in the market. The tool has got great demand. About this Spark, right? The advantages, its features, all this I'll be demonstrating in the tomorrow session, right? But as what is the course structure, right? What is that course content we'll be discussing, right? I'll just show you what we'll be discussing as part of this course. Some Hadoop components and Spark, right? So like big data Hadoop introduction. Second. Why Hadoop need of Hadoop data sources and HDFS, Hadoop distributed file system. We need to have the knowledge on this HDFS file system. It doesn't use databases as it got some drawbacks. Map reduce execution model, right? In Hadoop. And a scoop, SQL plus Hadoop. First two characters of this and last three characters of it form scoop, right? Import or export operations, how to bring data, how to pull the data from different databases, processing it, and after processed, the data need to be again taken to databases. Import and export operations, it's not for processing, it's just for importing data and exporting data, right? And filtering, transforming, all this. Yarn, yet another resource negotiator. So from Hadoop 2 version onwards, we got many architectural changes. Yet another resource negotiator. And as a Hadoop and Spark developer, you need to have the idea about at least one NoSQL database, not only SQL for schema-less behavior, random access. NoSQL advantage is record to record, different number of fields or columns can be maintained. In SQL, first record to last record, same number of columns need to be maintained, right? But in NoSQL, my first record with 3 fields, second record with 5 fields, third record with 10 fields, right? Record to record, different number of fields can be maintained, right? And as part of our course, I'll be discussing the HBase, one NoSQL database, HBase and HBase data modeling and CRUD operations, and Hive and HBase integration. And next, the important Hadoop component like Hive, which is used for data warehouse. For we use a language called HQL here, loading data and making the data structured and creating tables, internal tables, external tables. We're working with unstructured XML, JSON data, working with URL, weblog data, unions, joins, UDF, UDAF, UDTFs, right? Non-partition, partition table, indexing, bucketing, partitioning, static partitioning, dynamic partitioning, right? And now coming to this PySpark, right? Spark with Python. So up to now, that is what Hadoop components that we'll be discussing, right? Now PySpark. PySpark real-time use cases, PySpark session, PySpark context, Spark context, parallelized repartitioning, broadcast variables, PySpark RTD computations, RTD persistence or persistence features options, PySpark core computation, and increasing the number of partitions, groupings and aggregations, single grouping, single aggregation, multi groupings, multiple aggregations, group by key, reduce by key, various actions and transformations, right? Various one by one actions and transformations, count by key, count by value, sort by key. So one by one inbuilt transformations and actions, we no need to write huge coding. So various inner join, Cartesian, PySpark SQL data frames, right? Making the data structured using maps, RTD, PySpark, RTD, PySpark, show, row class, select, collect, with column renamed where, order by, group, join, union, one by one. All these APIs, right, with working examples. PySpark SQL functions, aggregate functions, window functions, date functions, JSON, right, read, right, and built-in functions, right, when, expression, lit, translate, overlay, to timestamp, percentage rank, count, distinct, row number, rank, dense rank, type lit, right, all this. And PySpark external sources, working with SQL statements, Hive integration, working with CSV, JSON, transformations and auctions on data frames, narrow and wide transformations, handling nulls, writing data back to external sources, deployment modes, local and cluster, PySpark applications, stages and tasks, driver and executor, deploying Spark applications to cluster, streaming integration with Kafka and PySpark, machine learning library, right? Yes. So all this in brief, right, in depth, we'll be discussing about entire data analytics with Hadoop and Spark, different APIs given and with many working examples, right? Yes. Fine. Yeah. So I'll be briefing about the Spark features, advantages, how it is used in the real time, right? In the tomorrow session, right? So this is what the course content. So every session will be video recorded. You will be getting the recorded videos of it. And clear notes will be provided, right? Fine. So this is a weekend batch. Yes, give me a minute, give me a second, right? I'll just come back with your queries. So on Saturday it will be like 2 to 2.5 hours. Sunday it will be 2 to 2.5 hours, right? 5 hours per week. So only on Saturday and Sundays it's a weekend batch. Yes. Fine. So it's totally of 12 weekends, right? 12 weekends. In depth, in brief, we'll be discussing, and all the softwares, everything I'll be provided, right, in through Google Drive, and videos also you'll be getting to Google Drive. Notes I'll be forwarding through mail, right? Fine. If you got any queries, you can go with your queries, and tomorrow also you can attend the session, right, at same time at 5:30 to see more on this. Mostly on Spark, I'll be briefing you, right, before I go with that basics of this big data, right? Yeah, any queries you have got, you can go ahead with your queries, right?
Sir, can we have an end project? I mean, live project, something like that.
So at the last, I'll be showing you the flow, right, on this.
Okay.
So do we need to have Java and Python programming knowledge before continuing with this course?
So here, PySpark means you need to have Spark with Python implementation. You need to have the knowledge on Python, basic Python, right? Yes. So the course is of 12 weeks, right? And the fee structure is 12,000, right? For which constitutes both Hadoop and Spark, right? Previously, there were two separate courses. Now both we combined, we are giving for an offer, right? It's like 12,000 for both, like 12 weekends. It goes for 3 months, right? And the Hadoop and especially for Spark, total implementation goes in Python, right? And anyone wants to also, because first 1 month or 1 month I'll be discussing on Hadoop, right, where we won't touch any Python there. So by the time we can update with Python, by the time when we start Spark, right? So people, and if you want Python also, I'll be also handling some Python batches, right? So those who wants Python also along with this, right? The package will be like 15K, right? Along with Python. You can join any of my Python batch, right? Which is going to be started. So, yes. So first 1 month we'll be having discussion on Hadoop, where we use, we'll be discussing about these Hadoop components. By the time we start, we can just update with Python. If anyone not aware about Python, right? Yes. So, yeah, any other queries, right? Yes.
Sir, since I've already joined Python just yesterday, so can it be clubbed with this course, my Python course?
Okay, if you're, yes, if anyone already done, right? So it was said, right, it's the 15K is that fee, right? So if anyone attending Python, if they want to get updated, right, 15K is the total package.
Okay, thank you.
And normal only for Hadoop and Spark. If you already had knowledge on Spark, it's 12K is the fee structure, right?
Okay, thank you.
Sure.
And I just wanted to understand, sir, the type of projects, like you will be doing a project, and will, like, at the end of this course or at the last 2 weeks or 3 weeks, what type of projects will be exposed to, or we will be doing on our own? Can we do on our own the projects once we complete the course?
Yes, totally. You will be getting command on this total Hadoop and Spark related APIs, right? When to use what, for what task, what to be performed, right? So will be during the course itself, right? We'll be designing many data flows, right? Spark, especially, it's a data flow language, right? So many data flows will be designing, right? With many working examples.
Okay, thank you.
Sir, you have a separate classes for Python, or it is there in the class?
So no, separate timings will be there, and means this Tuesday at 7 a.m. in the morning, I'm starting a Python batch, right? Morning 7 a.m., right?
When it's going to start?
On 31st of this month, after 3 days. At morning 7 a.m., right? At morning 7 a.m. there is a Python batch I'm going to start morning 7 a.m., right?
Okay.
And 31st of this month, and again 14th of this next, after 2 weeks, right? There is one more batch in 7 p.m., right? I'm going to start.
Sir, is there no batch for weekend because I'm working professional. Weekdays is not possible for me.
So most of the weekends I'll be dealing with Spark and Scala and Spark PySpark batches are there, and this data analytic batches, mostly this I'll be dealing with. But people, okay, there are some people previously who have joined, right? If he doesn't have knowledge on Python, even if you attend the session, that's fine. Otherwise, following the videos, that's fine if you're unable to attend. But there are no weekend batches. But whenever you have got any queries, people will be joining and you'll be asking the queries, right? Any 1 or 2 days, right? If unable to attend. Yes. No weekend batches for Python. No weekend batches for Python, but for this only we have got the weekend batches for this.
So this timings will not change, right? Or
No.
It will change.
This timing won't change. I have got other batches, right? Other timings. This will be.
Okay. Yeah, because this is convenient, so that's why if it changes,
Yes.
then my schedule will change.
Yes.
Okay.
So are
Thank
you
you.
covering the installation steps also?
What is it?
Installation steps.
Yeah. How to install on Windows, how to install on Linux, and how to work on this Anaconda, Jupyter, Spider, PyCharm, all this I'll be discussing, right?
Okay. And I heard like the pig and yarn is out of scope, so nowhere there is.
Pig, we are not discussing pig, right?
Okay. And what about deployment like yarn, so architecture? So that is also no more. So airflows, something kind of things you're using.
Pig, yeah. Apache pig is we are not discussing that pig. Apache pig is not discussed. So other components.
What about yarn?
So yarn architecture will be discussing. Yeah, only the architectural part.
Okay, and deployment means like nowadays they are using airflow. So instead of yarn, so nowhere they're using yarn architecture also.
So at the last, I'll be providing that knowledge on that.
Okay.
So
and if you
yes.
So you are covering the airflow also, right? So the deployment option.
So this is what you can once again just to go through all this course content, right? You will be getting this course content to your mail IDs. So all this in-depth knowledge on PySpark, all the APIs with many working examples, right? Yes.
Okay. And this PySpark, how it will differ from working in Databricks that's in cluster mode?
Yeah, that also how to work with the Databricks, that also I'll be discussing, right?
Okay. So and what about Delta live tables? Like you are covering?
What is it? No.
Delta live tables.
No, that is not covered here.
Okay. Thanks.
Okay, fine. Any other queries, right? Anyone?
Sir,
Fine.
how to pay the fees? I mean,
Yeah. Tomorrow, right? During the session, there will be. So you will be getting a mail, right? Whatever mail ID you have joined, you'll be getting a mail, right? They'll be giving the entire the payment process and procedure,
okay.
right? Through. Okay. And also tomorrow during the class in the chart panel, they will be posting the payment options, everything, right? In the chart panel. Okay, fine. Okay, fine. So
Hear me?
I'm stopping for now. So we'll continue tomorrow, same time at 5:30. You can follow the same link to see more on this, right? Tomorrow, mostly my discussion will be on Spark, PySpark, right? Introduction on this PySpark, the features, the advantages, all this, right? So I'm stopping for now. Thank you all for your time. Thank you.
Vijay?
Yes. Yeah.
Thank you.
Hello?
Yeah. Any query? Yes.
Can you hear me?
Yeah, I can hear you.
Already I opted for the Python and the data science and the tech of that. So already
Yeah.
that tech
You
will be on
you opted for.
Python, data science, and the 7 batch, seven batch.
Okay.
Python.
Okay, there's yes. People who are already said, right, only for Hadoop and Spark it is like 12K, and if anyone already doing Python here in this Durga soft, and like if anybody wants to update with Python, right, the fee structure is 15K. If you already have done paid for this Python and if you're updating with the Python, right, so your total package will be 15K.
I'm concerned about the timing of the classes.
Timing will be right every week on Saturday.
Already you said,
Five-
said that stack will be at the backend batch only.
This is a weekend batch, right? This is a weekend batch only.
No. Can you hear me?
Yes, I can hear you, right?
No, you said that full stack will be on weekend batch only. The 7 p.m. batch there. So this for
So all these are weekend batches. I'll be running from morning to evening, right? Many weekend batches on Scala, Spark with Scala, and Big Data Analytics, right? Many weekend batches. Yes. Okay.
I'll back to you there.
Fine. Okay. So I'm stopping here. We'll continue tomorrow, same time at 5:30, right? Fine. Yeah. So, good evening, all. So myself, I'm Vijay. I hold nearly 17 plus years of experience, which includes nearly 8 plus years of experience in Hadoop and Spark environment, right? So as part of today's demo, I'm going to cover the following topics. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
Yes, sir. Screen is visible, sir.
And thank you. So what is big data? Why Hadoop and Spark? And what are the drawbacks we see with the current databases, right? Drawbacks with current databases, right? Hadoop and Spark advantages. Hadoop and Spark advantages. Yes. Hadoop and Spark components. Hadoop and Spark job market. Fine. Yes. So in today's session, mostly I discuss about big data and Hadoop, right? In the tomorrow session, I'll be discussing mostly on Spark and advantages. Yes, its features. What is big data? What is big data, right? The name itself saying, right? Huge volumes of data. You see the current, how the data is stored currently, right? Data storage units like KBs of data, right? MBs of data, GBs of data, gigabytes, terabytes, petabytes, exabytes, right? Zettabytes, ettabytes, ottabytes, so on, right? Yes. So from TB onwards, we see like huge data, right? Or big data, right? So do you think like, okay, you should have seen KBs of data, MBs of data, or even GBs of data, right? But do you think like petabytes of data, is it getting generated in the current real world, right? 1 petabyte equal to, right, 1024 TBs. Already 1 TB is a large storage unit, right? Do you think like 1 petabyte, right? Yes, 1 petabyte equal to 1024 TBs. So already 1 TB is a large storage unit, right? 1 TB is a large storage unit. So here 1024 TBs forms a petabyte, right? It forms a petabyte. So do you think like petabytes of data or exabytes of data, is it getting generated in the current world? If so, examples of petabytes of data generation, petabytes of data generation. Talk about a banking sector. Yes. If you take example of any bank like SBI or HDFC, right? We see within the city, we see hundreds of branches. Within the entire state, we see thousands of branches, right? Within the entire country, lakhs of branches for SBI. Again, within each branch, we call, say like millions of customers, each customer making multiple transactions per hour, per day, per week, per month, per year. Each and every transaction need to be stored, right? So huge data. And forget about this, everyone aware about the social media like Facebook, right? Facebook. It has got users not only within the country, it has got millions and trillions of users throughout the world. What is the data generated by Facebook in a minute? How many posts and videos are getting circulated? What should be the storage capacity to store all that videos and posts, right? So not like you see, like it's what is the data generated means not in MBs or GBs, like terabytes and petabytes of data. Not only like Facebook, right? Today we have got many applications. Today, if we talk, like many applications are generating data in petabytes. They are generating data in petabytes, right? Yes. 1 minute, if I talk about 1 minute of transaction, right? 1 minute transaction, right? Yes. In a minute, how many FB post, Facebook post, right? Yes. What is the data generated by Facebook? In a minute, how many Twitter tweets? What is the data generated by Twitter in a minute? What is the data generated by Google, right? Google queries, right? What is the data generated by YouTube videos upload? YouTube videos upload, right? Yes. So huge data, right? What to store all the videos, everyone creating their own videos and uploading in the YouTube, right? What should be the storage capacity to store all the videos? And everyone, right, has got millions and trillions of users using email messages, right? Email messages. Each and every message need to be stored, right? What should be the storage capacity to store all these messages? Or bank transactions. Just now I was talking about the bank transactions, or if it like telecom transactions, or like Flipkart or Amazon transaction, right? Like e-commerce transaction. Everywhere we see like huge data, right? Yes. Not in GBs or TBs, petabytes of data. All these applications storing petabytes of data, right? Yes. Okay. Currently we have got databases, right? Currently we have got databases like we see like databases like Oracle, MySQL, right? We have got databases like Oracle, MySQL, DB2, SQL Server, right? All these databases, right? They are used for OLTP, online transactional processing, for day-to-day operations, right? But if you see, we have got some specialized databases. We have got some specialized databases. Databases used for data warehouse purpose, right? Like we got Teradata. If you heard about like Teradata and Netezza, Netezza, Vertica, right? Yes. These are used for OLAP, for data warehouse purpose, right? DWH, data warehouse purpose, right? Online analytical processing, OLAP, online analytical processing, right? Yes. Databases and specialized databases both are used for, right? Okay. Okay. Now these databases or specialized databases, they can handle data up to some extent, like databases in GBs of data, specialized databases in TBs of data, right? But to handle petabytes of data, right? We doesn't see these databases cannot handle like petabytes of data, right? As a solution to all these storage level problems, right? Not only storage and also processing level, right? We have got a framework like Hadoop for storage and processing. Later, I'll come back to this. What are the Hadoop and Spark services? But before that, if we talk about this, how this data is getting generated, data generations, and if we see data sources and data types, right? If you take, for example, if you take, this is your data available. This is your data, right? Available. This data got generated from the last 50 years. Assume that from 1973 to 2023, right? This is the data which got generated, right? If you compare this data, right? Yes, if you see from 2013 to 2023, last 10 years data comparison with previous 40 years, right? See, previous 40 years. Only like if you see 20% of the data has got generated from the last previous 40 years, and nearly 80% of the data what we see currently has been generated from the last 10 to 15 years, right? The reasons for huge data generation, especially from the last 10 to 15 years, right? Because of usage of technology, usage of smartphones,